Okay, good morning. And we'll try to cover some application layer. Okay, there are many application layers programs specified. So those red ones I'll try to cover. There are a lot of application layer programs. So first one is the domain name system. It's a client server program. So those programs can be divided into two, which can be used directly by the user like email, and those that support other applications. So DNS is a supporting program that is used by other programs such as email. So DNS client server program support email program to find the IP address of an email recipient. You know the uh, name of the recipient in terms of the English words. However, you don't know the IP address. So to find the IP address, this email program could use this DNS program. The user of email program knows the email address. However, the IP protocol needs IP address. So there is a DN. This is our user. He knows this name, but not the IP address. Now it would send it to a SMTP client, and this wonderful.com, those portion, this DNS client would serve to would send to a DNS server here. This is written client, but this is a server. So it's a client server type, and this would return the IP address. So it would go. Okay. So DNS client program sends request to DNS server to map the email address to corresponding IP address. That's the function. So how you have this mapping? You cannot have a single file in a host file. So you divide this large, huge information into small parts, and those each part is stored on a different computer. So host needs mapping. So the host computer needs a mapping. It will contact the closest computer holding the information. Okay. So we could have a flat namespace or a hierarchical namespace. So we normally follow the hierarchical namespace. So it is in different layers. So each name is made of several parts. So first part could define the organization. Second part would name of your like GCTCR.ac. AC is the name or nature of the organization, name of the organization. Third part defines the ECU, department in the organization. So a central authority would assign part of the name that defines the nature of the organization. Nature of the organization is like ORG, like those EDN, all this is the nature of the organization. So for which there is a central authority to assign part of the name. That's a part of the name that defines nature of the organization, name of the organization. EC, TCR and AC, those names are assigned by a central authority. So this is a hierarchical system. So you see this domain namespace was designed in this. So this is designed as a hierarchical way. So in this design, names are defined in a inverted tree structure. So you have a dot, that is the last one. Then you have this org or a com. This comes in the second layer. Then again you go down, down, down. So tree can have up to 128 levels. You can have, there is an inverted tree, root at the top, and it could have 128 levels. Each node has a label. So every node, so in a tree there are nodes. These are all labels. So likewise there would be label for every node. And each label can have a maximum of 63 characters. Now the root is a null, that's a dot, empty. DNS requires that children of the node, nodes that branch from the same node have different label, which guarantees uniqueness of the domain. So if there are 3 children from this node, these 3 should have different names. Okay. Otherwise, it wouldn't be unique. So these are the labels. So labels, you could have 128 levels, and this is 63 characters maximum. So at the end there is this dot. So this is a computer challenger at some division in some organization, which is an education, and this is this dot. So this EDU is at this level, that is a label at this level. FHDA is a label at this level. ATC is the label at this level, and this is the label at this level. So from here, you go on up to this root like this, challenger.atc.fhda.edu. So domain names and labels. Domain name is a sequence of labels which are separated by dots. Sequence of labels separated by dots, that is the domain name. Now, when you completely write like this, full labels and full dots, you refer to this as a fully qualified domain name. Okay. Now, sometimes you could have partially qualified domain name as well. Here dot is missing, here .com is missing. So partially domain name is within the department, amongst the computers, or within the college amongst the computer. You need not give the full domain name because that is already within a domain. So the last portions are no. So in that case, we could have a partially qualified domain name. Does not reach the root. When name to be resolved belongs to some site as the client. So sometimes within GEC TCR, you need not have fully qualified domain name. You can use partially qualified domain names. So from the root, you have these domains, and you could have subdomains. So like that it goes, domains and subdomains. So domain is a subtree of the domain namespace. The name of the domain is the domain name of the node at the top. So this domain name would be com, or this could be edu. And top of the subtree. Figure shows some domain. Note that a domain may itself be divided into subdomains. The domain could be again be divided into subdomains. Okay. So generally we have domains, we have a hierarchical name structure, and we have a root at the top, which is the null. So hierarchy of names servers, very inefficient, also unreliable to have just one computer store a huge information. So a single computer storing all this information is very inefficient and very unreliable. So we have this hierarchy of name servers. So we distribute information among many DNS servers. Okay, the portion of information would be there in some DNS server, like that it is distributed among many DNS servers. So one way is divide whole space into many domains based on first level. We let the root stand alone and create as many domains as there are first level. First level is org, com, gov, etc. So we would have a hierarchy of servers in the same way as we have hierarchy of name. Like we have hierarchy of names, you would have hierarchy of servers, root server and all these servers. This also would be in a hierarchy, all these servers. They'll be holding the information. Information is for mapping the domain name to IP address. So when we want to send an email, we have only the domain name, we need the IP address. So that mapping would be available in all these servers which are distributed globally. What a server has authority over is called a zone. A server has an authority over some portion which is called the zone. It's a contiguous part of the entire tree. If a server does not divide domain into smaller domain, then domain and zone are the same. In case that zone is not divided into subdomain, zone refers to domain itself. Now there will be a database called a zone file in the server, and it will keep all the information for every node under that domain. So there would be many other nodes in that domain that would be kept in the zone file, and server divides domain into subdomain. Domain and zone refer to different things. So domain and zone need not be same. A zone would be same as domain if there are no subdomains. Otherwise, they refer to different things. Zone is a bigger thing, and a domain is a smaller one. So, zone and domain. Okay. So, root, zone, domain, like that, it's divided. So basically, we have a root server. But this root server usually does not store any information about domains, but delegates its authority to other servers, keeping reference to those servers. So certain servers would keep only a file with the referencing to other servers. And there are several root servers, each covering the whole domain namespace, and these servers are distributed all around the world. So this DNS defines two types of servers, primary and secondary. The primary server loads all information from a disk file. The secondary server loads all information from primary server. When a secondary downloads information from primary, it is called zone transfer. So there are again division into primary and secondary. Primary keeps only uh, the linkages, and this would secondary would actually have this all information. The secondary has to download the information from primary. And now, actually, we have different types of domains. One is this generic domain. Three types actually. Generic domain is org, edu, etc. These are called generic domain, and correspondingly we have servers there. And there are country domains like in.india or US for US. There are country domains. So, and the third one is an inverse domain. Sometimes you would have the IP address. You want the domain. In that case, there are servers belonging to the inverse domain. From the IP address, you could get the domain name. So DNS in the internet is divided into different sections. So root, then many servers belonging to the generic domain like edu, org, com, etc. Then many servers uh, with this country domain like .in, .us, then the inverse domain from IP to domain name matching. So generic domain. So generic domain is this edu, gov, org, com, etc. So generic domain defines host according to the generic behavior. Each node in the tree defines a domain which is an index to the DNS database. Index to the address. So this actually they are holding this domain name and address. So generic, there are 14 labels from the tree. First level are the generic domain. There are 14 possible labels. So government institution, commercial institution, organization, network support center, non-profit organization. There are 14 such generic domain labels. And the country domain again, like because all books are basically from that US side, you don't have this IN here. This is US, this is France, like that. So here we have domains related to country. IN is there. Then there is inverse domain. So you have this IP, find out the DNS, that is map IP address to a name is the inverse domain. So three categories, basically you can divide into three different sections: generic domain, country domain, and inverse domain. Now resolution, that is actually what is taking place. Mapping a name to an address or an address to a name is called name address resolution. So the actual function taking place is this resolution. So DNS is designed as a client server application. Host needs to map an address to a name or a name to an address calls a DNS client called a resolver. So DNS client is called by the host, and that's called a resolver. Resolver accesses the closest DNS server with a mapping request. So it will approach the nearest DNS server with a mapping request. If the server has the information, it satisfies the resolver. Otherwise, it either refers the resolver to other servers or asks the other servers to provide. So the client host needs a mapping, needs to resolve to approach the nearest server. That server would have the information, then it would give it. Otherwise, it will approach other servers or it will direct the host to approach other servers. So one type is called recursive resolution. So basically resolution means mapping. So recursive means client is approaching this server at this level. This server doesn't have this. So it will approach the higher server. It would again approach other server. From the root it would go to some other server, again to some other server. Finally this server has it. Now it will come back, and it obtains, client obtains. So mapping a name to an address or an address to a name is called name address resolution, and this is called recursive resolution. Okay. Then iterative resolution is there. The client is approaching one server. It is not having, it is sending back it to the client. And the client would approach the next server. If it is not having, it would send back. Then again it goes to this. Again it comes here. Then again it goes here, 8, 9, 10. Then finally from here it would get this. So these are two approaches. One is iterative resolution. So resolving the IP address, the corresponding to the domain name. And this is the recursive resolution in which this server would somehow find out by contacting other servers and get the information. Okay, so what is happening is we are actually transmitting query messages and we are receiving response messages, and there would be a header section and data, and there would be a header format and data format, everything is detailed. Everything takes place as DNS messages. Query would be sent and response would be received. Query message consists of a header and question records. So you put the questions, and the response message consists of header and also the question and also the answer records, authoritative record, additional record, all these are available. So finally it is resolved. And this header itself has a format. It would have a number. For every query there should be a number, then some flags are there, the number of question records, all these are the formats pertaining to the header. So basically DNS messages are communicated, query is given, responses are received, and there is a database in all these DNS servers at different hierarchical levels. It is spread all over the world, and thus we obtain the IP address corresponding to the domain. So that is what occurs. Now, when we create a new domain, there is something called registrar, a commercial entity accredited by this. We had seen this firm. And registrar first verifies that the requested domain is unique and then endates it into the database. This is how you create a new domain. Now, this domain name system is a dynamic one. It should be updated dynamically. So, whatever data is there in the servers, so we need to update it. So, there are DHCP and DNS server, and all these updations have to be taken place. Dynamic domain name system is a mechanism to update the domain name. So this domain name server, we had seen that the UDP and TCP are the transport layer protocol. The DNS can use services of UDP or TCP, and the port number used is 53. You can refer to the table, just check what is this 53. So DNS either uses UDP. I think maybe if the data size is less, it uses UDP, or greater than 512 or something, it uses TCP. So either service, UDP or TCP, can be used by the DNS. So that is one function. So we had seen that email is a application which uses the service of DNS. So email, you would send an address. So that has to be converted to an IP address for which you use this DNS. And the host would approach the DNS service. Now the second application is email. One of the most popular service is the email. Their designers probably never imagined the popularity of this application program. Now we will just see what are these components in this: the user agent, message transfer agent. Uh, Simple mail transfer protocol is the protocol for message transfer agent, and the message access agent for this post office protocol and IMAP will see that. So what are the components? So we'll see four scenarios. This is explained by, generally it is explained by explaining four scenarios. So first scenario is sender and receiver users. They are having application program. Okay, and they are connected to a system. Both users are connected to a system. There are user agents, those are programs running on these hosts, and they are connected to a system. Then we will see they are connected to different systems like that, four scenarios. Directly connected to a shared system, the administrator has created one mailbox for each user where the received messages are stored. Mailbox is part of a local hard drive, a special file with permission restriction. So normally we have this Alice Bob type of characters in all of these examples. So Alice runs a user agent program. It's a program to prepare message and store it in Bob's mailbox. So this is the scenario. Both are connected to a shared system in which there should be a user agent program at this Bob's end and user agent program at this Alice end. So when sender and receiver of an email are on the same system, we need only two user agents. So we will see again three more scenarios. The second scenario, they are not on the same system. They are separated by a network. So second scenario, in an email, Alice needs to use user agent program to send her message to the system at her own site. This is a mail server called mail server. There would be a queue to store messages waiting to be sent. Now, Bob also needs a user agent to run the program to retrieve the messages stored in the mailbox of the system at his site. The messages, however, needs to be sent through an internet from Alice's site to Bob's site. So in this case, two message transfer agents are needed. So user agent is for running this program, and message transfer agent client and message transfer agent server is required here. So one is the client and one is the server, transfer agent. These are all protocols and programs here. We'll see this as SMTP. And so this is required at this end, client version and server version at this end. So when sender and receiver of an email are on different systems, they are connected over a network. We need two user agents, which are programs, and a pair of message transfer agents, client and server. Now the third scenario. So here Alice is not directly connected to this system, but via a LAN or a WAN. So we use this scenario. So Alice connected to a LAN in an organization that uses one mail server for handling emails of all users. So all users need to send their message to this mail server. Alice calls user agent, which calls MTA client. MTA client establishes connection with MTA server on this system. And systems on the Alice site queues all messages it receives. It then uses an MTA client to send messages to system at Bob's site. The system receives the message, stores in Bob's mailbox, and this user agent would get it. So this is the scenario, third scenario. When the sender is connected to the mail server via a LAN or WAN, we need two user agents, two pairs of MTA, client and server. So here there is this MTA client, MTA server, MTA client, MTA server. Now we go to the fourth scenario, which is the final scenario. Bob is also connected to his mail server by a LAN or WAN. After the message has arrived at Bob's mail server, Bob needs to retrieve it. Here we need another set of uh, client server which is called message access agent. So here there is a difference between message access agent and message transfer agent. So here we have introduced message access agent. So this is sort of that is uh, shown here. Message transfer agent is sort of pushing from client to server, and here it is different. It is pulling from client is pulling from the server. So that sort of agent is called message access agent. So this here basically it is a push type uh, activity going on in message transfer agent, whereas at the receiver it needs to pull from the server, and that agent is called message access agent. So when both sender and receiver are connected to mail server via LAN or WAN, we need two user agents, two pair of message transfer agent, and a pair of message access agent. This is the most common situation today. So normally we have this scenario. So these are the components required in the for this email: user agent, message transfer agent, and message access agents. Now, what are the services of the user agent? We have just shown that it is a program. So user agent is a software package program that composes, reads, replies, and forward messages. It also handles mailboxes. So these are the various functions of this user agent. Some examples are these mail, file, ELM. So this could be command driven. Command driven means basically in the beginning everything was by writing commands on a terminal. So that is these are those examples. Later on, this GUI came when this Windows 95 etc. came. Only this GUI based things came. So these are some other initial user agents, GUI based. Now we know the format. There would be a body in the email, there would be a header in the email, and there would be a envelope. So this is the basic structure of an email. And we have a local path and the address of the mailbox and an at and domain name of the mail server like gmail.com at, and this is the address of the mailbox. This is the email address format. Now this one is a multi-purpose internet mail extension is another component. MIME. Electronic mail has a simple structure, but it can send message only in this format, ASCII format. So this is the format of this message transfer agent. So when you have a user agent which is giving a non-ASCII code, you need this one, MIME, to convert it into ASCII. So that is the function of this multi-purpose internet mail extension in which is a supplementary protocol that transforms non-ASCII data into this NVT ASCII data and delivers them to client MTA to be sent through the internet. At the receiver, it is transformed back from this ASCII to non-ASCII using this multi-purpose internet mail extension to the user agent. Now, this is the range of this simple mail transfer protocol. Is this actual mail transfer is done through message transfer agent (MTA). To send mail, a system must have a client MTA. To receive mail, system must have a server MTA. The formal protocol that defines the MTA, client and server in the internet, is called simple mail transfer protocol. So this MTA, the server, this client and server, this is based on the simple mail transfer protocol. Two pairs of MTA client server programs are used in most common situation. The fourth scenario which I have seen. So this MTA portion, this MTA is by this SMTP, MTA. MTA portion is this is implemented as this protocol, client server in the simple mail transfer protocol. So this is the range of this SMTP, this portion, from here to here and from here to here. That's the SMTP range. Now basically again, SMTP uses command and responses to transfer messages between MTA client and MTA server. So mail transfer process is process of transferring a mail messages occurs in three phases: connection establishment, mail transfer, and connection termination. So here there are two other protocols that push type: Post Office Protocol and Internet Mail Access Protocol, IMAP. The first and second stages of mail delivery use SMTP. However, SMTP is not involved in the third stage because SMTP is a push protocol. It pushes the message from the third stage, needs a pull protocol. So pull protocol is the client must pull messages from the server. So for which we have Post Office Protocol and Internet Mail Access Protocol. So this is the range of SMTP and this is the range of POP. Okay, so that is regarding these two things we had seen today. Is the one is DNS and another one is the email. So we'll see two more